Hello viewers, so we have this question that says for a certain transverse wave, the distance between two successive crests is 1.20 meters, and 8 crests pass a given point along the direction of travel every 12 seconds. Calculate the wave speed. Now we're given to say we have a transverse wave. Now when we talk about a transverse wave, we're talking about a type of wave whose particles are traveling perpendicular to the direction of the wave or to the direction of propagation of the wave. Now, what we are saying is this. For example, if we have the direction of the wave to be this, is going in that direction, the particles will be traveling like this. All right, so that's what we have. Now, the highest displacement in the positive y direction, which is this part here is called the crest. And the highest displacement in the negative y direction, this is what we call the trough. So we are saying this part here is called a crest, and this part here is called a trough. Yes. So when you hear of a trough, just not say we're talking about this part, the highest displacement in the positive y direction, and a crest is the highest displacement in the positive y direction, and a trough is the maximum displacement of these particles in the negative y direction. All right. So now, what we should understand is when we are given to say we have a distance between two successful crests, this crest and that crest, what we are given there is basically wavelength. So we should note to say, if we are saying two successive crests, this is equal to wavelength. Now wavelength is given by the symbol lambda. So this is wavelength. And then also when we are told to say we have two successful, I'll just use that to say successful. Now, in this case, we're no longer talking about crest, but we're talking about troughs. This is also equal to wavelength. And if we have the distance between one successful, so we're talking about one successful trough and one successful crest. This is also equal to wavelength. So when you're given such kind of information in questions, you need to notice to say they've given you wavelength indirectly. So whenever you hear two successful crests, that's wavelength. Whenever you hear two successful troughs, that's wavelength. And whenever you hear one successful trough and the one successful crest, the distance between those two is also wavelength. Yes. So what we are saying is the distance starting from here, uh, the distance from here up to there, this distance here is wavelength. This is the distance between two successful crests. And also the distance from this point here to that point there, this is also wavelength. So this is wavelength. And also the distance from this point here, this point up to that point, this point here to this point here. This is also wavelength. So you can see these are basically distances between two successful crests, two successful troughs, and the one successful trough and one successful crest. So we are given those as wavelength. This is to tell you to say the information we are given as 1.20 meters is basically our wavelength. So wavelength is equal to 1.20 meters. So that's what we are given from the question. Now, the formula we need for this question is we are looking for speed. So speed is equal to wavelength multiplied by frequency. We already have the wavelength to be 1.20 meters. All we need to find is the frequency. Now, how do we find the frequency? For frequency is defined as the number of cycles per unit time. So it can be number of cycles per unit time. It can be the number of crests per unit time. It can be the number of troughs per unit time. That will still give you frequency. So in this case, we are talking about crests passing in a certain direction per unit time. So to find our frequency using the information, we're going to say the frequency is equal to the number of crests. So we'll say number of crests divided by time. That's to say per unit time. And this will give us, we have 8 crests that are passing every 12.0 seconds. All we have to do is do mathematics there. 8 divided by 12 is giving me 0.66666. It goes like that. So I'll round it off to 0.667. So the unit here is hertz. So we'll have our frequency is 0.667 hertz. Now that we have our frequency and we have our wavelength, we can find our speed. So our speed will be equal to, our wavelength is 1.20 meters, and this will multiply by 0.667. Now hertz is the same as per second, so we'll say s minus 1. And this will give us, when we punch our calculators, we must get, so we have 0.8 meters per second. So this is our answer. The speed will be 0.8 per second. Get rid of that and write it 0. So this is 0.8 meters per second. So that's our speed. So this is how we solve this type of questions. If you found this one to be helpful, please subscribe to our channel. If you are on Facebook, follow our page. And if you are watching us on TikTok,